Let's solve Unit 9 Data Communication and Computer Networks questions. What will be the order of the following fields in a frame relay frame format? Under virtual circuit networks, we have two topics. One is the frame relay and the other one is ATM. We will see about frame relay in this question and about ATM in the next question. What is frame relay? This is a virtual circuit wide area network. It is a relatively high-speed protocol that can provide some services not available in other WAN technologies such as DSL, cable TV and T-lines. So we have seen about LAN, MAN and WAN in computer networks. Local area network, metropolitan area network and wide area network. Frame relay belongs to WAN. Let's see the frame relay structure now. We have 5 fields. The first and the last field will be the flag, and in between we have 3 fields: address, information, FCS. They are asking the order of the fields in the frame format. So this is the order. It will start with flag. Flag is available in option A, address option C, information option D and FCS is option B. A, C, D, B. Option number 1 will be the right answer. Now let's see about this frame format. Flag field, address field, information field are okay. What about FCS? FCS is frame check sequence. And under this address field, we have DLCI, C by R and EA. So DLCI is data link connection identifier. C by R is command or response. EA is extended address. So the number of corresponding bits are also presented here. Then we have FECN, BECN, DE and EA again. FECN is forward explicit congestion notification. BECN is backward explicit congestion notification and DE is discard eligibility. EA is again extended address. Please go through this frame relay format once so that it will help you in some other question also. Next question. Which of the followings are type of interface in an ATM network? Now let's see about ATM network. It is asynchronous transfer mode, which is abbreviated as ATM. This is a cell switched network. The user access devices called endpoints, and these endpoints are connected through user to network interface called UNI. This is U, this is N and this is I. The endpoints are connected through UNI to the switches inside the network. So here we get an idea about one interface. The switches are connected through network to network interfaces, that is N and I. N and I. This is the architecture of an ATM network. Here you have the endpoints and here you have the switch. In between you can find the user to network interface called UNI. Similarly, here also you have UNI. The switches are connected through an interface called network to network interface. That's why you can see NNI here. Whenever endpoint to switch connection is there you can find UNI. Whenever switch and switch are connected, you can find NNI interface there. User to network interface and network to network interfaces are present in ATM network. User to network interface is option B and network to network is option C. So from this we can mark option number 2, B and C only as the right answer. Next question. Match list 1 with list 2. List 1 has the protocol types and the concerned protocol is listed in list 2. All these protocols belong to a sublayer in the data link layer called media access control. So the ones that I am going to list below come under MAC layer. We have random access protocols, Aloha, CSMA, CSMA, CD, CSMA, CA. Carrier sense multiple access is CSMA, CD is collision detection and CA is collision avoidance. Then we have controlled access protocols. Under that we have reservation, polling and token passing. We have channelization protocols. Under that we have FDMA, TDMA and CDMA. So first let's complete 3 options in the match. Channelization protocol will be mapping to TDMA here. A2. We have only one option with A2. Next we have random access protocol. We have Aloha here. So C will be mapping to 1. It is here. Controlled access protocol is reservation. D is mapping to 3. What about bit oriented protocol? This is under the topic data link control. High level data link control, that is HDLC. This is a bit oriented protocol for communication over point to point and multi-point links. Now B will be mapping to 4. B4 is there. Option number 2 will be the right answer. Next question. An IPv4 packet has arrived with the first few hexadecimal digits as shown below. How many hops can this packet travel before being dropped? The data belong to what upper layer protocol? We are talking about IP packet. IP means it is in network layer. So from network layer, what is the upper layer? It is the transport layer. Now let's see the IPv4 packet. In hexadecimal, you will have 0 to 15 representation. From 10 to 15, it is of letter A to F. From 0 to 9, it is the decimal number 0 to 9. When you want to represent a hexadecimal digits, you will need 4 binary digits. That is what is mentioned as 4 bits is equal to 1 hex digit. They are asking about the number of hops and they are asking which upper layer protocol will be there. The time to live, also called as TTL field, is giving the number of hops, and the protocol layer here, this is going to give the upper layer protocol. These two fields are going to be the answer of this question. But we have to find which hexadecimal digit is coming to these two fields. Let's start. Version has 4 bits. It means one hexadecimal digit is dedicated to version field. Then we have HLEN. This header length is of 4 bits. So we will take one hexadecimal digit. Service type is of 8 bits. 8 bits means we have to take 2 hexadecimal digits. So we will take 2 hexadecimal digits. 4 bits will make 1 hexadecimal digit. 8 bits will make 2 hexadecimal digit. 16 to 31 is totally 16 bits, which gives the total length. 16 bits in the sense you have to take 4 hexadecimal digits. 1, 2, 3, 4. 0, 0, 1, 8. Identification field is again 16 bits. So we can go for 4 hexadecimal digit, which is 0, 0, 1, 0. Flag is 3 bits and fragmentation offset is 13 bits. We need not worry about this 3 and 13. The question is not about these two fields. So we can add 3 plus 13, which makes them as 16 bits. What is the next 4 digits here? 0, 1, 1, 0. This will be for both the fields together. Then we have time to live 8 bits. 8 bits means you have to take 2 hexadecimal digit. So this is the time to live fields hexadecimal digit, and protocol also we have 8 bits. So this is the protocol related hexadecimal digit. Now time to live is actually 04. When you convert 04 to decimal, it is again 4 only. We can mark 04 as 4 hops because the first question is about the number of hops. Which protocol does 06 mean? 06 is nothing but 6. 6 is referring to TCP. We can mark 06 as TCP. 4 hops and the next value will be TCP. It is matching in option number 4. Option 4 will be the right answer. Next question. Match list 1 with list 2. We are presented with the line coding scheme in list 1 and the average bandwidth is listed in list 2. Under unipolar category we have NRZ. Under polar category we have NRZL, NRZI and biphase. Under bipolar category we have AMI. Under multilevel we have 2B1Q, 8B60 and 4DPAM5, and under multi-transition we have MLT3. The question is about NRZL, 2B1Q, 4DPAM5 and MLT3. Just pick the average bandwidth value. NRZL, A will be mapping to B is equal to N by 2. A4 is available in 2 options. Next we have 2B1Q. It has an average bandwidth of n by 4. B is mapping to 1. We have B1 here. So this is ruled out. Already these two are ruled out. What about 4DPAM5? The bandwidth will be n by 8. C is mapping to 2. MLT3 will have a bandwidth of n by 3. D is mapping to 3. From this we can say option number 3 will be the right answer. Next question. IP is responsible for what communication, while TCP is responsible for what communication? Let's see a statement about TCP. The transport layer is responsible for process-to-process delivery of the entire message. Transport layer protocol is TCP. So TCP is responsible for process-to-process delivery. Where do you have process-to-process in the second half? You have it here, which makes it evident that IP is responsible for host-to-host. So this is IP and this is TCP. Option number 4 will be the right answer. Now let's see the other options. Option 2 is just exchanged, so we can rule that out. Regarding the first option, node to node, host to host is almost the same meaning, so we can rule it out also. Regarding socket to socket is fine, but host to node is not a good option for TCP. So in this case, we can also rule out option 3. When you are sure about an answer, you can go ahead. But when you are not sure about an answer, you should be sure that other 3 are not going to be the right answer. So that's why while learning from previous question papers, you have to understand why options are wrong and why one option is correct. Next question. Services provided by point-to-point protocol. Let's see the services list. Point-to-point protocol defines the format of the frame to be exchanged between devices. It also defines how two devices can negotiate the establishment of the link and the exchange of data. It is designed to accept payloads from several network layers, not restricted to IP alone. Authentication is also provided in the protocol, but it is optional. The new version called multi-link point-to-point protocol provides connection over multiple links. One interesting feature is that it provides network address configuration. This is useful when a home user needs a temporary network address to connect to the internet. There are lots of services given here, so we will try to match with the options. Option A is talking about frame format, and here we have the first point stating it defines the format of the frame. So A is there. Establishment of link is option B. Here it talks about, it defines how two devices can negotiate the establishment of the link. So B is also there. C is talking about flow control. We have not seen any statement regarding that. D is talking about sequence numbering. It is also not talking about that. And authentication is provided in the protocol, but it is optional, is given here. So E, authentication, is also a part of the answer. From this we can say option number 1, A, B and E only will be the right answer. From this we can understand C and D are wrong. Along with C and D, there are also services that are not provided by point-to-point protocol. Here the question is asking for the services. Another question may turn up in any other question paper asking which of the services are not provided. So for that question, these points will be useful for you. It does not provide flow control. This is what option C is about. It has a very simple mechanism for error control. A CRC field is used to detect errors. If the frame is corrupted, it is silently discarded. The upper layer protocol needs to take care of the problem. Lack of error control and sequence numbering may cause a packet to be received out of order. Lack of error control as well as it is lack of sequence numbering. So the point D is mentioned here. They have mentioned about error control here and they say it's lacking error control. If you have a confusion, you can take the statement as it is just used to detect error. It is silently going to discard it if it finds the frame to be corrupted. So error control means it should detect and inform it somewhere so that measures can be taken accordingly. And the last point, it does not provide a sophisticated addressing mechanism to handle frames in a multi-point configuration. Next question. According to the Nyquist theorem, to produce the original analog signal, one necessary condition is. Let's see the exact statement of the question. According to the Nyquist theorem, to reproduce the original analog signal, one necessary condition is that the sampling rate be at least twice the highest frequency in the original signal. Where the option is matching, we have 2 times only in 2 of the options. Rule out the rest 2. Now read the statements. Sampling rate must be at least 2 times the highest frequency contained in the signal is perfectly matching. Option number 1 will be the right answer. What about option 2? Sampling rate must be at least 2 times the lowest frequency is actually wrong. That's why we are ruling out option 2 also. Now we will see a diagram here. They have given the Nyquist rate as 2 into the highest frequency, that is F max. And here they say if the analog signal is low pass, as we see here, the bandwidth and the highest frequency are the same value. If the analog is band pass, the bandwidth value is lower than the value of the maximum frequency. Next question. The sequence of fields in an IP datagram will be. So let's see the IP datagram diagram once again. These questions are coming in the question papers for the past 3 to 4 sessions. So it's better you get a good learning from this IP V4 packet. Let's mark the options inside the diagram. We have flags in A. We will mark A here. Then we have options. Options plus padding is given here. So we will mark B here. C has protocol. Let's mark C here. Identification is D. We will mark D here. Service type is E. We will mark E here. Now arrange it according to the sequence. First row has E. Then we have identification, then flags. So D followed by A, then C in the third row, then the final row B. E, D, A, C, B. Option number 1 will be the right answer. Next question. What is the total delay called the latency for a frame size of 10 million bits that is being set up on a link with 20 routers, each having a queuing time of 2 microseconds and a processing time of 1 microsecond. The length of link is 5000 km. The speed of light inside the link is 2 into 10 to the power 8 meter per second. The link has bandwidth of 6 Mbps. Now let's understand about latency. The latency or delay defines how long it takes for an entire message to completely arrive at the destination from the time the first bit is sent out from the source. So the first bit is sent from the source. From there the clock starts till the entire message completely arrives at the destination. That time is actually called the latency. Say for example, if I am going to send something at 9 o'clock and the message is going to completely reach only at 9:20, it means there are 20 minutes in between. I can send at 9, then 9:1, then 9:2. I can send till even 9:05. But when does this 9:05, the last message is going to reach here, is what they say how long it takes for an entire message to completely arrive at the destination. But when does the time start? It starts from the first bit. We have a formula for this. Latency is equal to propagation time plus transmission time plus queuing time plus processing delay. You have to calculate all these 4 values and add them up. What is propagation time? The time required for a bit to travel from source to destination. It is given by the formula distance by propagation speed. What about transmission time? It is the time between the first bit leaving the sender and the last bit arriving at the receiver. The message size divided by bandwidth will give the transmission time. What about queuing time? This is the time needed for each intermediate or end device to hold the message before it can be processed. They have given 20 routers are present in between. So queuing time is for those 20 routers. Even the next term, processing delay, or we can call it as processing time, is for these routers to process them. I have a sender here, I have a receiver here. In between the sender and the receiver, we have 20 routers. So sender will send here, it will go for many hops and then it will reach the receiver. Those routers have some queuing time and processing delay. Now let's get into the calculation part. So we are going to take the given values from the question for every time. So first we will start with propagation time. It is distance by propagation speed. What are the values we can pick from the question? Distance is equal to 5000 kilometer and propagation speed is 2 into 10 to the power 8 meter per second. The length of the link is actually the distance. The speed of the light is actually the propagation speed. Now we will substitute. What is distance? It is 5000 kilometer divided by the propagation speed is 2 into 10 to the power 8 meter per second. Since we have meter and kilometer, we will convert this into meter again. So 5000 into 10 to the power 3 meter divided by 2 into, we can split 10 to the power 8 as 10 to the power 3 into 10 to the power 3 into 10 to the power 2. So 10 to the power 8 can be split as 3 into 3 into 2 parts, so that it will be easy for you to cancel. This is meter per second. I am striking off meter and meter. This per second, when it goes to the top, it becomes second. 10 to the power 3 and 1 10 to the power 3 will get cancelled. 5000 is actually 5 into 10 to the power 3 divided by 2 into 10 to the power 3 into 10 to the power 2 are still remaining. Once again we will cancel 10 to the power 3 and 10 to the power 3 in the numerator and denominator. We have 5 by 2 into, we will bring this 10 to the power 2 to the numerator. This becomes 10 to the power minus 2 seconds. What is the value of 5 by 2? It is 2.5 into 10 to the power minus 2. This is equal to, you have to move the decimal point to the left side. So this will give a value of 0.025 seconds. So all the 4 units are going to be seconds. Let's have a plus here. Next we are going to calculate transmission time. It is the value of message size divided by bandwidth. Message size is equal to 10 million bits. So it is taken from frame size of 10 million bits and bandwidth is equal to 6 Mbps. This is directly given here. So first I will write this as 10 million divided by the bandwidth 6 Mbps. Regarding 10 million, for 1 million you will have 6 zeros. So this is 10 into 1 million, which means 1 million, if it has 6 zeros, we can represent it as 10 to the power 6. So we can take this as 10 into 10 to the power 6 divided by 6 into, message size is already in bits and this is megabits. Mega can be converted as 10 to the power 6 again. Hope you remember 10 to the power 3 is 1 kilo, 10 to the power 6 is 1 mega. So in that case, we are converting mega to 10 to the power 6 and now this is just bits per second. Bits and bits get cancelled. So per second goes to the top and it becomes second. Now we can cancel 10 power 6 and 10 power 6. We can cancel 2 5s are and 2 3s are. 5 by 3 will give a value of 1.666. It goes on and the seconds will be retained as it is. We will add 1 point more number of 6 to this time. The third value will be the queuing time. So here they have mentioned link with 20 routers, each having a queuing time of 2 microseconds and processing time of 1 microsecond. So the value that we are going to take for queuing time is number of routers is equal to 20. The queuing time for one router is 2 microsecond. This is for one router. You have to calculate it for 20 routers because between the sender and the receiver you have 20 routers. The number of routers is equal to 20 into, this is actually a direct calculation. For one router they have given you a value. they have told you that there are 20 routers in between, which means you have to multiply with the number of routers to get the total queuing time. What is the queuing time mentioned? It is 2 microsecond. 20 into 2 is 40. What is actually microsecond? It is 10 to the power minus 6 seconds. How do you represent this? You have two values here, so you have to put 4 zeros after the point and write 40 here. We'll write the value here 0.000040. You have 6 numbers after the decimal point. Make sure the transition time is going to also have 6 numbers after the decimal point. Next we will calculate the processing time. Again we are going to consider the number of routers into processing time for one router is given as 1 microsecond. So this is going to be 20 into processing time for one router is 1 microsecond. This is equal to 20 into 1 is 20 into 10 to the power minus 6 seconds. This is equal to, same way you have to place 4 zeros and 2 0 next to that. Now we will even add up 0.000020. So we'll just add the units in queuing time and processing time here. We will add it even here. 0.025, 1.12345 0.12345 then 0.12345. So I have written all the digits with respect to decimal point. 6 plus 0 will give 6, 6 plus 4 is 10, 10 plus 2 is 12, 1 plus 6 will give 7, we have 5 plus 6 as 11, 1 plus 2 is 3, 3 plus 6 is 9, 0 plus 6 is 6 and 1 is here actually. What is the answer here? 1.691726 seconds. This is perfectly matching in option number 2. Option number 2 will be the right answer. With this, we are completing Unit 9 solutions.